Welcome to Brain Vision.
In this problem, we have a ball of a given mass, which is at the center of a cart. Now the cart is eventually at rest and the ball is given velocity v0. Now we want to find the velocity of the ball and the cart just after the ball strikes one end of the cart at A. We also want to determine the time that it will take for the ball to strike A and then B and return to the center of the cart. So going one step at a time, let's look at after the first collision. So this is the first collision with A. If we take the left direction to be positive and we use the conservation of linear momentum, that is the momentum before the collision must equal to the momentum of the cart and the ball after the collision. Initially, the cart is at rest, so it has no momentum, which is 0. The ball has momentum m v0 since it's given an initial velocity of v0. After the collision, we have momentum for the ball is mvb plus the momentum for the cart, which is its mass, capital M, times vc. And so essentially we have too many unknowns in this problem. So the next thing we will do is apply the coefficient of restitution, again taking the horizontal components to the left as positive. Now the coefficient of restitution, E, is equal to Vc minus Vb, the difference between the velocities or the relative velocities after the collision over the initial velocity v0. And so we can see here that we have two equations with the same unknowns. So if we go back to the first equation, we can see that m v0 is equal to m vb plus m big M over little m times vc. And from the second equation, E v0 is equal to vc minus vb. So we can see from here that v0 into 1 plus E is equal to 1 plus big M over little m times vc. So essentially we found vc in terms of the initial velocity v0. So vc, if we rearrange this equation, is v0 into 1 plus E times the mass of the ball, little m, over little m plus big M. And so if we know the masses and we know the initial velocity, we can calculate vc, the speed of the cart after the first collision, as this equation. Now that we have vc, we can easily go back and find vb. So vb is equal to v0, which is this is vc, v0 into 1 plus e to the power m, times m rather, over little m plus big M, which is vc, minus e v0. And so we can simplify this as v0 into m plus me minus me minus capital M times E all over little m plus big M. And so this simplifies even further into v0 as v0 into m minus big M times E over little m plus big M. So here we have the velocity of the ball and the velocity of the cart, VC and VB, after the first collision. Now we will look at the relative velocities after each collision in order to find the total time for the ball to strike end A and then end B and land in its original position of the center of the cart. So the relative velocity on the cart after the first collision, we'll use the coefficient of restitution again. E is equal to this relative velocity over the initial velocity v naught. And so the relative velocity, which is what we need, is E times v naught. So this is the velocity after the first collision. And similarly, the relative velocity after the second collision, this is at end B, we'll use the coefficient of restitution E is equal to this relative velocity over E v naught, which is now the initial velocity. And for this part of the journey, the relative velocity v is equal to E squared v naught. We just rearrange this equation. So therefore, the total time that it takes we'll call t, and t is equal to the length of the cart d over v naught plus the time it takes after the rebound going from A to B, 2d over e v naught. Actually, in this case, 2d is the length of the cart, d is a half of that length, plus the distance from B back to the center, d, over its now velocity, which is E squared v naught. And so we get the total time for this to occur to be d over v naught into 1 plus 1 over E all squared.